Greetings, folks. Are you ready for some football? Well, first you have to answer this question. Suppose the weights of NFL linemen are normally distributed with a mean of 330 pounds and a standard deviation of 10 pounds. What weight puts a player in the top 20% of NFL linemen? So here's the distribution of weights of offensive linemen. Of course, you see the center is 330 pounds, which is the mean. I just drew a line that I thought kind of looked like about 20% of the distribution. Remember, the question is, what weight do you need to put you in the top 20%? And I put question marks under that because we don't know what that weight is. So now let's look at this on a standard normal distribution. Of course, the center of a standard normal distribution is 0. I drew another line that I think picks up about the top 20% of the distribution. And again, I put question marks because we don't know what that z-score is yet, but we will in a second. So to find the z-score that corresponds with the top 20% of the distribution, we're really looking for the z-score that corresponds with the bottom 80% of the distribution. And that's because the standard normal table shows cumulative percentages. So here's a standard normal table. Remember, I can't show you the entire table, so I just kind of focused in on the part that was most relevant. And to look for the z-score that corresponds with the bottom 80% of the distribution, we're looking for a value of 80% in the standard normal table. And I've highlighted in red. It's the closest value to 80%. It's 0.7995. So it's just a tad bit less than 80%. And that corresponds with a z-score. So you see it's 0.84. So a z-score of 0.84 has about 80% of the distribution to the left of it. So here we're showing this on the standard normal curve. So a minute ago when we saw the standard normal curve, I had question marks for the z-score, and now we can actually fill it in as 0.84. So again, at a z-score of 0.84, you have about 80% of the distribution is below that, which means 20% is above it. Because again, the question was, what weight puts you in the top 20% of offensive linemen? So of course, we haven't answered that question yet. All we have is a z-score. But remember, we use this simple formula here to transform variables from its value to a z-score. So likewise, we can start from a z-score if we know the mean and standard deviation to tell you what the x value is. So here we have our z-score of 0.84. The mean of the distribution was 330 pounds. The standard deviation is 10. So we can do a little bit of algebra here. If we take 10 and multiply it by 0.84, that equals xi minus 330. So of course 10 times 0.84 is 8.4. That equals xi minus 330. If you add 330 to each side, you get 338.4 equals x. So we can take that weight and actually put it on our normal distribution of weights of offensive linemen. Remember, the center of this distribution is 330. Again, earlier when we saw this distribution, we had question marks because we didn't know which weight corresponded with the top 20% of weights for offensive linemen, but now we know that value is 338.4. So we can go back to our original question, original setup, that is, suppose the weights of NFL linemen are normally distributed with a mean of 330 and a standard deviation of 10. What weight puts a player in the top 20%? Well, it's 338.4 pounds or more. So if you weigh that amount or more, you are the top 20% of offensive linemen in the NFL.